Hi guys, I am Pranali Latthe. Roll number is 2003057.
And I am Manasi. My roll number is 2003069.
Today we are going to explain insertion sort.
So let's start.
Let us understand what is sorting. Sorting refers to ordering data in an increasing or decreasing fashion according to some linear relationship among the data items.
The most IMP question in front of us is what is the sorting algorithm? A sorting algorithm is used to rearrange a given array or list elements according to a comparison operator on the elements. The comparison operator is used to decide the new order of elements in the respective data structure.
Now let us understand what is insertion sort. In insertion sort, the array is virtually split into a sorted and unsorted part. Values from the unsorted part are picked and placed at the correct position in the sorted part.
Now see the strategy behind the insertion sort. Insertion of elements in arbitrary order as follows. Begin with sequence E of n elements in arbitrary order. Initially, assume the sorted segment contains the first element. Let x be the next element to be inserted in sorted segment. Pull x out of the way, leaving a vacancy. Repeated compare x to the element just to the left of vacancy. And as long as x is smaller, move that element into the vacancy. Else, put x into the vacancy. Repeat the next element that has not yet examined.
Now let us see the real-time application of insertion sort, that is playing cards.
Now let's see how it works. Let there be n number of elements in a given array. We start by making the second element of the array, that is element at index 1, that is key. We compare the key element with the elements before it. In this case, the element at index 0. If the key element is less than the first element, we insert the key element before the first element. If the key element is greater than the first element, then we insert it after the first element. Then we make the third element the key and we'll compare it with the elements to its left and insert in the correct position. Now after picking the key, we start iterating over elements to the left of the key. We continue to move towards the left if the elements are greater than the key element and stop when we find the element less than the key element. Insert the key element after the element which is less than the key element, and we go on repeating this until the array is sorted.
Now let us start the example of insertion sort. So let us consider the array of size 6 with elements 7, 3, 5, 4, 2, 6. Now we are going to sort this array. For iteration 1, consider key is equal to 3. Now compare 3 with its previous element, that is 7. 3 is smaller than 7, so 7 is placed at position second and 3 will placed at position first. Now for second iteration, let key is equal to 5. Now compare 5 with its previous elements, that is 3 and 7. 5 is less than 7, so 7 will be shifted to the right side. Now compare 3 with 5. 3 is smaller than 5. There will be no change and 5 will be occupied vacancy. For iteration 3, consider key is equal to 4. Compare 4 with its previous elements, that is 3, 5 and 7. 4 is smaller than 7, so 7 will be shifted to the right side. Compare 4 with 5. 4 is less than 5, so 5 will be shifted to the right side. Now comparison is done between 4 and 3. 3 is smaller than 4, so there will be no change and 4 will be occupied vacancy. For iteration 4, consider key is equal to 2. Compare 2 with its previous elements, that is 3, 4, 5 and 7. 2 is smaller than all these elements. So the numbers that is 7, 5, 4 and 3 will be shifted on the right side one by one, and 2 will occupy first position. Only one element that is 6 is remain unsorted. So in this iteration we will sort it. Now consider k is equal to 6. Compare it with 2, 3, 4, 5 and 7. 6 is smaller than 7, so it will shifted to the right side, and vacancy will shifted to left side. Now compare 6 with 5. There will be no change and 5 will occupy vacancy. Now we will get final sorted array, that is 2, 3, 4, 5, 6 and 7.
Let's understand logical part. Here simple and small code is given. In this code we are using two loops. One is for and other is while. In for loop, I is equals to 1, I is less than n, I plus plus means I is initialized to 1 and given that I should be less than n, and increment the value of I by 1. If given condition I is less than n is satisfied, then loop get executed and set that one element in array of index I as key element and set j as j minus 1. Now check second loop. Here other loop is while loop. While j is greater than is equals to 0 and a of I is greater than key, then this loop will execute. Now set array of index j to element at array index j plus 1. That means a of j plus 1 is equals to a of j. Then decrement j, that means j is equals to j minus 1. And lastly set key at element of index j plus 1. That means a of j plus 1 is equals to key. This whole logic of this insertion sort. So time complexity is for best case is big O of n and worst case and average case is big O of n square.
Now let us check out some advantages of insertion sort. 1. The pure simplicity of the algorithm. 2. The relative order of items with equal keys does not change. 3. The ability to sort a list as it is being received. 4. It is efficient for small data sets. 5. It is adaptive. 6. It is better than selection sort and bubble sort algorithms. 7. It is a stable sorting algorithms. Thank you guys for watching our video.